it asks us, where does the absolute value function have a turning point? Now, does anybody in here know what the absolute value parent graph function has a turning point at? Do you know what the absolute value function even looks like? No? I think when I show it to you, hopefully it rings some bells. So what did I just tell you on the previous? If you don't know what a parent graph looks like, we'll type it into your calculator. So there's the parent graph. Just y equals the absolute value of x. So I'm going to go to my y equals menu. Does anybody know how to find the absolute value on your calculator? Yeah.
You can go to the catalog and press.
Okay, that's always a backup way to find anything, is go to the catalog and go alphabetical order, find absolute value. Under math. Yep. So if you hit math and scroll down, just kidding, scroll over to number, it's going to be your first option there. So if I hit the absolute value of x, and then, oops, I don't know where you guys left off your window. My window left off negative 20 to 20 and negative 700 to 700 for some reason. It's always a good idea with parent graphs to recenter your graph, negative 10 to positive 10, negative 10 to positive 10. Does anybody know a shortcut to doing that? Chris?
Did you reset your calculator?
How would you do that? The second plus second thing? Oh, hit the button on the back? Yeah, that would do it. But I don't really want to reset everything. If you just go to Zoom, 6 says Z standard. That negative 10 to 10, negative 10 to 10 viewing window is your standard starting window. So if you just hit Zoom 6, that will immediately reset your graph negative 10 to 10, negative 10 to 10 on both axes. It's just quicker. So there is our, does that look familiar? Yes, okay. So it's kind of like the quadratic in that the vertex is at 0, 0. If you go to your table, and again, right now my table is starting at 26. I'm going to go to my table set. I'm going to get my table to start at 0 and take another look at that. So your vertex is at 0, 0. Then on either side of that, you've got 1, 1, and you've got negative 1, 1. You've got 2, 2, and you've got negative 2, 2. So if you kind of sketch that, it's that perfect diagonal line. On either side. So my vertex originally, and this problem number 7 is asking about my turning point, which is your vertex. My vertex is initially 0, 0. But this point is undergoing 3 transformations. We've got this half multiplier, we've got this minus 8, and we've got this plus 3. There's 3 transformations. Which one happens first, Eric?
The half.
Think order of operations. The negative 8. And also anything horizontal is going to happen first. So you're always going to, if your x-coordinate's going to change at all, that's what's going to change first, because you always start within the function. And this is shifting 8 units to the right. So that's going to change our x-coordinate to an 8. There's transformation number 1. And then the half, Eric. Now, that's vertical, so that's going to affect our y-coordinate, and half of our y-coordinate is going to make that 0 become a 0. It's not going to affect it at all. So there's my half dilation, and then plus 3. Vertical shift up 3. So 8, 0 becomes 8, 3. So we've done that skill before, but I knew like the parent graph of an absolute value function would get you. Right now, you guys know 3 parent graphs. I think that's all you should know. You should know a linear parent graph, y equals x. That's just that picture. You should know a quadratic, y equals x squared. And again, to ever make these more exact, you can grab points off your tables. And y equals the absolute value of x. Those are the only 3 right now you're expected to know. The only other thing that's possible, if they're not doing a traditional function, they just might show you a picture. Like, they could show you just any random picture like this. No, it's hard to see, but see how that's like a wavy, weird line? You don't know the equation for that, but they could just say, okay, here it is. This is f of x, this is your parent graph. Now shift it right 3 units. And you should be able to do that with any picture that they show you. But these are the only 3 where they might not show you the picture, but they'll just give you the equation. Okay? And those are the 3 you're expected to know. 8 is a concept we've done. It's just, I think it's presented a little bit in a tricky way. So they give us an original function. It's a quadratic of some sort, because it's x squared. And it tells us what those x-intercepts are. And you can sketch it if you want to. I don't think you necessarily need to. But we know that if it's got an x-intercept at -9 and at 3, and we know it opens up or down? Up, because it's a positive x squared. We know it looks something like that. That's our original function. Then they are asking us, well, where does this function have x-intercepts? And the challenge is, without plugging that into your calculator and just using it, okay, obviously that would be a cheater method, but without doing that, you should still logically be able to figure out where they are. What did they do from this equation to this equation? In a lot of ways, those 2 equations are the same, but they replaced these x's with what down here? Chris? 3x. So essentially, if this is f of x, this is f of 3x because they plugged 3x in. And what transformation would that constitute? Horizontal or vertical? Dilation, right, because it's a multiplier. Stretch or compression? Good. Compression by 1/3. Absolutely. Perfect. So if you're going to horizontally compress these 2 points, this one being -9, this one being 3, if you compress -9 by 1/3 and smush it in there, where's it going to be? -3. Very good. If you compress 3 by 1/3, where is it going to be? 1. Awesome. Answer 4. So that's a tricky presentation of it, but I think it's a great one. I think it's something we should be able to make sense of. And number 12. Is the function, and this is an absolute value function, a one-to-one function? Let's review. Does anybody remember what a one-to-one function is? There are regular functions, and then there are these special functions called one-to-one functions. Elena?
Where there's only one x input and only one output.
Correct. So if you're looking at a table of values, no x value can repeat itself. That'll make it a function. But then no y value can repeat itself either. That'll make it a one-to-one function. How about visually, if you're looking at a picture?
It should pass the vertical line test and the horizontal.
Vertical line test and the horizontal line test. So the best idea here, I think, is going to be to look at a picture of this. You can just type it into your calculator. Given that we just talked about this, though, we talked about what the parent graph looks like. How has this parent graph been shifted? What does this do? Which way does the x minus 6 inside the absolute values move it?
Right.
What's your first name again?
Corey.
Corey. Right 6. So that's going to take your vertex and move it over here. And then up 2. So your new vertex is going to be there. Does that pass a vertical line test? Yes. Uh-oh, Olivia. Horizontal. It does pass vertical. It does not pass horizontal. So this would be no. And your x explanation is going to be kind of paired with your sketch. Don't just say, because it doesn't pass the horizontal line test if you're not showing me the picture. Just sketch a picture of it and say, no, the graph of the image to the left does not pass the horizontal line test. Not image, graph of function, I should say. Does not pass the horizontal line test. Cool. So those are the main three that I feel like were somewhat brand new, or at least would probably look brand new to you guys. Just taking a quick glance, this is definitely not brand new to you, part C on 13, but it was something we struggled with. So they show us f of x, yet they're asking us for f inverse of -3. Take a minute and see what you think that would be. And try to use that shortcut without actually drawing the f inverse function. Raise your hand if you already have an answer prepared. 4 of you. Okay, which tells me maybe only the 4 of you really know how to do this, because you either just know how to do it or you don't. So it's not really something we should be trying to figure out. You're not confident, Bella?
No.
What do you think?
I graphed it, so I...
That's cheating. I mean, it's not. On a test, I would encourage you to do whatever you got to do to make it accurate. So what'd you get?
1.
Okay, what did Chloe get?
-5.
What did Corey get?
I got -5.
And who was my 4th person?
-5.
-5. Uh-oh, Bella. So I'm curious how, if you graphed it, you got it wrong. Where are your points? How did you graph it? What was your methodology for graphing the inverse function?
I don't even know, honestly.
Okay, help her out. What should be your methodology for graphing the inverse function? Because that's definitely something you should be able to do. Yep.
I just went down 3 and then over.
Yeah, that's correct. But if you're, that is the correct method that I want. But now that Bella's got me onto a new tangent, how should you graph a function's inverse? Oh boy. Yeah?
You pick whatever points for the function and you flip back.
Right. All you do is you take the critical points, or as many points that will give you the shape, and you just flip-flop them. So this point, for example, that's 1, 3. So on the inverse, that's going to map to 3, 1. You just flip-flop them. Remember? All things x and y's on inverses just flip-flop. Your domain becomes your range. Your range becomes your domain. Your x-intercept becomes your y-intercept. Your y-intercept becomes your x-intercept. So any xy point, you just flip-flop those values. So that brings us back to the cheater, well, not the cheater way, the actual real conceptual way I'd like for you to be able to do this problem. When they give me -3 here, they're asked, that's giving me the x-coordinate as it would be on the inverse function. So if that's the x-coordinate or the input on the inverse function, then which coordinate is it supposed to correlate with on the original function? It's the x-intercept of the inverse, which should be, not the intercept, it's the x-coordinate of the inverse function. So it's going to be the y-coordinate of the original, yes? Does that make sense? Again, all things x's and y's changing. So if it's the y-coordinate on the original and it should be -3, that's where what Haley said is correct. So she knew that's the y-coordinate -3, so she went down 3 units. and figured out the x that was paired with that, and it was negative 5. So on the inverse function, we have the point negative 3, negative 5. On the original function, that was the point negative 5, negative 3. Good? Okay. So for your homework, do the review sheet. I will send out answers via Remind in about 15 minutes. I got to do it first so that you have them, so that you can check them. If you need me tomorrow morning, I will be here. After school today's a little tough.